Have you ever looked up at the night sky, filled with countless stars, and wondered when we'll finally go out there and explore? Every sci-fi movie, from Interstellar to Star Trek, has sold us this dream of humanity becoming a galactic civilization. But what if I told you that every single one of them is lying? The cold, hard truth is this: humanity will likely never leave the Milky Way. Not in 1,000 years. Not in 1,000,000. Never. Why? Because the universe has built a prison around every single star system, and it has secured it with 3 unbreakable locks. Each lock alone is a death sentence for our interstellar dreams. Together, they represent a final cosmic checkmate. Let's start with some perspective. Voyager 1, humanity's fastest and most distant spacecraft, has been traveling for nearly 50 years. It's now about 24 billion kilometers away from home. That sounds incredibly far, right? But at its current speed, it would take Voyager 1.6 billion years just to exit our own Milky Way galaxy. By then, the sun will have long since swallowed the Earth. This isn't a problem of technology we can eventually solve. It's a problem of fundamental physics. It begins with our first lock, the speed of light. In 1905, when Albert Einstein published his theory of special relativity, the world of physics was turned upside down. Not because the equations were complex, but because they revealed a brutal and unforgiving cosmic law. Nothing with mass can ever reach the speed of light. That's 299,792 kilometers per second. While it sounds fast, on a cosmic scale, it's agonizingly slow. But the most terrifying part isn't the speed limit itself. It's why the limit exists. As an object with mass accelerates, its relativistic mass increases. As you get closer and closer to the speed of light, your mass starts approaching infinity. Imagine trying to push a car. Now imagine that with every push, the car gets heavier. Soon, it's as heavy as a building, then a mountain, then the entire planet. To push it just 1 more inch, you would need an infinite amount of energy. This isn't a technological challenge, it's a cosmic curse. And the universe is telling us, you can try to run, but you will never escape. Now, let's say, just for the sake of argument, we could overcome this. Let's say we invent a spaceship that can travel at 90% the speed of light. This brings us to our second lock, energy conservation. How much fuel would a journey like that take? The answer is so staggering it borders on despair. According to Einstein's famous equation, E equals mc squared, accelerating just 1 single kilogram of mass to 90% light speed requires the energy equivalent of 2,000 Hiroshima atomic bombs. A crude starship, with life support and supplies, would weigh at least 100 tons. The energy needed to get that ship up to speed would be immense. To get a clearer picture, you would need to convert the entire mass of the planet Jupiter into pure, usable energy just to get the journey started. And Jupiter, by the way, is 318 times more massive than Earth. And it gets worse. That's only the energy needed for acceleration. Once you arrive at your destination, you need to slow down. Unless you want your ship to arrive as a fireball of superheated plasma, you'll need the exact same amount of energy to decelerate. So for a round trip, you'd need 2 Jupiters worth of energy. Some people might say, what about nuclear fusion? It's the power of the stars. Well, let's look at that. The most efficient fusion reaction we know of converts only 0.7% of mass into energy. This means that to power our round-trip journey, we wouldn't need a Jupiter's worth of fuel. We'd need the equivalent of 1,400 Jupiters. Our solar system only has 8 gas giants. Where are we supposed to find the other 1,392? The universe simply doesn't provide enough fuel for the ticket. But even if we found a magical energy source, we'd run straight into the third and most vicious lock of all: time dilation. This is where science fiction becomes a personal tragedy. Imagine you were an astronaut on that near-light-speed ship. You're traveling to Proxima Centauri, the nearest star to our sun, just over 4 light years away. For you and your crew, thanks to the effects of time dilation, the journey there and back might only feel like a few years. Let's say you're gone for 2 years, ship time. You return to Earth, excited to share your discoveries. But when you land, you find that 10 years have passed. Your children are now teenagers who barely remember you. Your parents have aged a decade. Your friends have moved on. The world you left behind is gone forever. The farther you go, the more heart-wrenching it gets. A journey to the center of our Milky Way galaxy, about 26,000 light-years away, might feel like 20 years to you. But upon your return, you'd find that 50,000 years have passed on Earth. Humanity, your language, your culture, everything you ever knew, would be an ancient civilization studied in archaeology textbooks. You wouldn't be a traveler, you'd be a ghost, a relic from a forgotten time. This isn't space travel, it's a one-way ticket to temporal exile. But here's the kicker. Even without these 3 unbreakable locks, we are still prisoners. We're not even talking about leaving the galaxy anymore. We're just talking about leaving our own solar system. Most of us think of the solar system ending at Neptune or Pluto. But the true edge of the sun's gravitational influence is a vast, diffuse sphere of icy objects called the Oort cloud. It's estimated to be about 1 light year in radius. That's nearly 9.5 trillion kilometers. Remember Voyager 1? Our fastest, most distant probe? At its current speed, it would take 18,000 years just to cross the Oort cloud. That's longer than all of recorded human history, from the first cave paintings to today. NASA's Helios 2 probe once reached a record speed of 70 kilometers per second. Fast enough to travel from New York to Beijing in under 3 minutes. But even at that incredible speed, it would take 4,300 years just to exit our own solar system. And here's the catch. These high speeds were achieved using gravitational slingshots around planets. Once a ship leaves the solar system, there are no more planets to get a boost from. Its speed becomes fixed, a lonely bullet wandering through the void, never stopping, but practically never arriving anywhere. What about those brilliant new ideas, like breakthrough starshot? In 2016, Stephen Hawking and billionaire Yuri Milner proposed a project to send tiny, gram-sized probes to Proxima Centauri. The idea is to push them with a massive, Earth-based laser array, accelerating them to 20% of the speed of light. It sounds fantastic, a true leap forward. But let's look at the numbers. The project would require a laser array covering 100 square kilometers, with a power output of 100 gigawatts. That's roughly the entire power generation capacity of China, all focused on pushing a probe that weighs less than a paperclip. And even if we built it, it's a one-way trip. The probe has no way to slow down. It would zip past Proxima Centauri in a matter of hours, with barely enough time to snap a few blurry pictures. It couldn't carry any meaningful scientific instruments. Sending data back across 4 light-years would be another monumental challenge. It would be the most expensive and elaborate piece of space dust ever created. So, what does this all mean? Does it mean we should give up? No. The universe has given us a magnificent cradle in our solar system, with wonders we have barely begun to explore. The drive to explore is part of what makes us human. But perhaps our destiny isn't to conquer the stars in person, but to reach for them with our minds, our telescopes, and our ever-expanding knowledge. The universe has shown us an infinite expanse of breathtaking beauty, a cosmic ocean of stars and galaxies. But it has also placed it behind an unbreakable wall of glass. We can look, we can learn, we can marvel, but we can't touch. And that might be the most beautiful and cruel truth of all. Thanks for watching. If you found this journey through cosmic realities as fascinating as I did, consider liking this video and subscribing for more. See you next time. Why haven't we found aliens? Why haven't we left our solar system? The sci-fi dreams we grew up with, of humanity spreading across the stars, seem more distant than ever. Every time we think we've found a way out, the universe presents a new, more impossible lock. Is interstellar travel just a fantasy? Let's look at the science, the real, hard science, and confront the truth about our place in the cosmos. First, let's tackle the most popular idea, cryosleep. To just freeze yourself and wake up thousands of years later at a new star. Sounds simple, right? But the problem isn't the cold. The real enemy is ice. When water freezes, it forms sharp, jagged crystals. Inside your body, these crystals would act like microscopic daggers, puncturing every one of your trillions of cells. They'd shred your DNA, turning your genetic code into confetti. Most importantly, they would annihilate the delicate network of neural connections in your brain. Think about it. Everything that makes you asterisk your memories, your personality, your love for your family, your favorite songs stored in the precise arrangement of those connections. If they're destroyed, the person who wakes up won't be you. It would be a blank slate, an empty shell. or more likely, no one would wake up at all. Even if by some miracle, we could invent a perfect freezing method that prevents ice crystals, a new killer awaits in the void. Once you leave the protective magnetic bubble of our solar system, you're exposed to the full force of galactic cosmic rays. These are high-energy particles traveling at nearly the speed of light. Over a journey of thousands of years, this constant bombardment would relentlessly mutate your DNA. It would systematically damage your nerve cells, turning your once living body into a mound of decayed tissue inside a coffin-like pod. You wouldn't be hibernating. You'd be slowly rotting in space. Okay, so cryosleep is out. What about the other classic sci-fi solution, the generation ship? A colossal vessel, a self-contained world, carrying thousands of people on a slow, multi-generational journey to the stars. The idea is that the descendants of the original crew will be the ones to finally arrive. This sounds more plausible, but the numbers reveal a slow-motion catastrophe. To maintain a healthy gene pool and avoid the problems of inbreeding, a starting population needs at least 500 people, probably more. Now let's calculate the supplies for a 10,000-year trip. Each person needs food, water, and breathable air. Conservatively, that's at least 2 kilograms of supplies per person per day. Do the math. For 500 people over 10,000 years, that's 36.5 million tons of just the basic necessities. This doesn't even count the weight of the ship itself, the farming equipment, the life support systems, the medical supplies, the tools, the computers, or anything for entertainment. The final ship would easily weigh over 100 million tons. It's 10,000 times heavier than the largest aircraft carrier ever built. To get a behemoth like that moving at any meaningful fraction of the speed of light, you'd need an absurd amount of energy. The fuel requirement would be equivalent to the mass of hundreds of Jupiter-sized planets. We're right back to an impossible engineering problem. But even if we could build it and launch it, the most dangerous obstacle isn't physics, it's human nature. History is filled with examples of small, isolated societies, and the pattern is depressingly consistent. They tend to fall into authoritarian rule, rigid dogma, superstition, and eventual collapse. The first generation of the crew would remember Earth and be driven by the mission. Their children, born in the endless night of space, might feel a sense of duty. But what about the third generation? They would start to question why they're trapped in a metal can, chasing a ghost planet they've never seen. By the 10th generation, Earth would be a myth. By the 100th, the original mission would be forgotten, replaced by tribal rituals and new religions forged in the dark. The advanced technology that kept them alive would become inscrutable magic, maintained by a priesthood that no longer understands how it works. Inevitably, it would fail. The ship would become a drifting tomb, a monument to a civilization that forgot its purpose and lost itself in the void. So, if we can't sleep our way there, and we can't sail our way there, what about a shortcut? A wormhole? Tunnel through space-time? Connecting to distant points in the universe? General relativity, Einstein's masterpiece, does allow for them mathematically. But there's a catch, and it's a big one. To keep a wormhole open and stable, you need something called negative energy, or exotic matter. This is stuff that has negative mass and negative gravity. Instead of pulling things together, it would push them apart. Does this fantastical material exist? In over 70 years of searching, through countless experiments in particle accelerators and cosmic observations, we haven't found a single shred of evidence for it. Not a hint? It remains purely theoretical. And even if we found some, the amount required is staggering. To stabilize a wormhole just 1 meter wide, big enough for a person to pass through, you would need an amount of negative energy equivalent to the mass of an entire galaxy. It's a galaxy containing 200 billion suns. We're talking about building a door with a key that may not even exist in our universe. The universe itself seems to laugh at our attempts to find a loophole. But the final, most insurmountable prison wasn't discovered in an equation. It was discovered by looking at the sky. In 1998, astronomers made a shocking discovery. The expansion of the universe is not slowing down. It's accelerating. Some mysterious force, which we've named dark energy, makes up 68% of our universe and is actively pushing everything apart, faster and faster. This has a profound and chilling implication. The galaxies we can see today, those beautiful spirals of light in our telescopes, are speeding away from us. In about 10 billion years, all but our closest galactic neighbors will have accelerated beyond our cosmic horizon. Their light will never reach us again. It will disappear from our sky forever. The universe is actively cutting the lines of communication between civilizations. This might be the ultimate answer to the Fermi paradox, the question of where is everybody? It's not that there are no other intelligent civilizations out there. It's that cosmic expansion has isolated every galaxy, turning them into solitary islands in an ever-widening ocean of nothingness. We are all prisoners, locked in separate cells. We might hear the faint echoes of our neighbors from billions of years ago, but we can never meet them, can never shake hands. This sounds like a tragedy, doesn't it? Final cosmic verdict of solitary confinement? But is it? Let's take a step back. Is being trapped in the Milky Way really a prison sentence? Our home galaxy is a kingdom of 400 billion stars. 400 billion? If you were to visit one new star every single second, it would still take you over 12,000 years to see them all. Within this prison are wonders beyond our wildest imagination. Blazing blue giant stars, ancient red dwarfs, older than the sun, city-sized neutron stars spinning hundreds of times a second. There are black holes that warp the fabric of reality, rocky worlds like our own, colossal gas giants, planets made of pure diamond, and rogue worlds wandering alone in the dark. The sheer richness and diversity of our own galaxy exceeds all human fantasy. Maybe this confinement isn't a curse, maybe it's a blessing. It forces us to abandon our childish dreams of conquering the universe, and instead focus our attention on this one precious, irreplaceable home. It teaches us humility, gives us a profound sense of responsibility. If intelligent life is truly rare, then humanity might be the Milky Way's only pair of eyes. Its only conscious mind might be the universe's only way of knowing and appreciating itself right here in this corner of space-time. So the next time you look up at the star-dusted arc of the Milky Way, don't see a cage. See your heritage. See an infinite inheritance that is ours and ours alone. To explore, to understand, and to cherish. We may never leave our galaxy, not because we are weak or incapable, but because we were always meant to belong here. This is our home, and the adventure is just beginning. Thanks for watching. If you found this perspective interesting, consider subscribing for more journeys into science and the cosmos.